Okay, the goal of Lab 3 was to calculate the mass of an unobservable object, or the black hole, through the observation of an object's motion which is acted on by the gravitational force of the black hole. In this case, it was a star. So the mass of the black hole was found to be 4.011 times 10 to the 31st kilograms. This was calculated by a computer model with the initial conditions of the star mass equal to 4.73 e to the 27, the time step of 86,400 seconds, or 1 Earth day, and the position of the black hole as 2.0 times 10 to the 10, negative 4.0 times 10 to the 10, and 0 for the z-axis in meters. So this value will remain constant because the mass of the black hole is so much bigger than the star that the force barely acts on the position. The mass was then calculated by finding the parallel and perpendicular components of dp/dt, and since it can be assumed here that F net is equal to dp/dt, and the only significant component of the net force is going to be the gravitational force, then the F net can be found as positive g, which is the gravitational component of 6.7 times 10 to the negative 11 times the mass of the star times the mass of the black hole divided by the distance between the two squared. So this formula is manipulated later to find the mass of the black hole. However, there's a problem here because for the different values in the CSV file, the F net and potentially the distance could change. So we have to calculate the mass for each point and then find the average and the standard deviation between the two. So in order to do this efficiently, we used a code. So here I have subbed in my star mass and my delta t, and then the velocity was calculated for the x and y component by finding the change in the velocity divided by the time. So it's here, this is for the x component and the y component, and then it's for each point and it's iterated through in the while loop. From here, then the net force and the mass were found through this while loop here. So the final and initial velocity were calculated for 3 consecutive points, and then were used to find the momentum in this line by multiplying by the star mass. And then the dp/dt was found for these two momentum values by subtracting or finding the difference between the momentums and then dividing by delta t. So since we're using the assumption of Newton's second law that F net is equal to dp/dt, we have now found the F net. So from here we find the dp/dt parallel and the F net perpendicular, the dp/dt parallel dp/dt perpendicular, which will give us the F net parallel and F net perpendicular. So these lines of code here give us the dp/dt parallel, which is basically the magnitude of P final minus magnitude of P initial divided by the time step, and then multiplied by the direction vector. And then the perpendicular is found by taking the difference between the dp/dt and dp/dt parallel that was calculated a second ago. So from there, the position of the star is updated so that it continues to read through the CSV file and calculate for each consecutive point. So after that, the black hole mass was found here. And so this is the gravitational constant, and then this is the gravitational law from earlier, modified in order to actually generate the mass of the black hole. So what if we had applied a black hole with a different mass but the same motion? Basically, it wouldn't be possible to calculate the new mass because the prediction is based on the motion observations, not originally on the mass. So basically, if the motion track had stayed the same, it would continue to calculate the same mass. And this is based on the principle that if the mass was different, the forces acting on it would be different, and so then the motion would also be different. So then what does all this mean? It's really, this lab was really just an estimation of the mass based on the motion. It may vary slightly based on the point, which was shown by the mass that was generated. And so it basically made the assumption that dp/dt and Fnet are the same, but they're actually different because Fnet is used to describe forces on the system, while dp/dt describes the motion, and it's basically just an observation. So that's basically it, but before we go, I'll run my module so you can see the motion of the star around the black hole. So that's basically what my motion looked like. All right, that's it. Thank you.